When we talk about the rate of change, we're talking about a relationship of one changing variable with respect to another. And mostly we've used the relationship between x and y. So when we drew from that relationship, the rate of change was found by looking at the rise over the run. Now we use the Greek letters D to talk about the small change of y over the small change in the x value, and that we know to be a slope. So we represented dy over the dx. So you can see that the rates and slopes have a simple connection. Now you know that calculating the rate of change of a function is also known as finding its derivative. So a derivative is simply a measure of how much one thing changes compared to another. But the rate can be anything per anything. For instance, the rate can be, temperature versus time. Or it may be height of something versus time, or it could be prices of stocks with days trading, area or volume versus radius or height. And we know that we've already done velocity versus time in kinematics. Okay, so let's look at elasticity of a human skin. And it says the quantity of a chemical in a human skin, which is responsible for its elasticity, is given by this equation, where T is the age of a person in years. So presumably in our first question, when we've got T is equal to 0, we mean that someone who is obviously born. And in that case, we'll note that they have 100 quantity of this chemical. Now, if we go to Q is equal to at a time when a person is 25 years old, we end up with 100 minus 50, which is 50 quantity of chemical. And when we are looking at a person who is 100 years old, then it seems that 10, the root of 100, that person will end up having no quantity of chemical. In all these questions, as with this one, I encourage you to use technology to graph these functions. I use Desmos. By looking at this graph, I can now look at the rate of change by looking at the slope. And so I will see that at the top, I have a very high or very big slope, negative slope. And as I continue down, okay, I indicate this by smaller and smaller, they're quite big, by smaller and smaller and smaller little negative signs. That means that my negative slope becomes less steep. Well, what does that in reality mean? Well, it means that in the early stages of your age, before you're 20, the chemical responsible for the elasticity decreases quite sharply. It begins to decrease less and less and less as time goes by. Okay, so now let's look at it mathematically. We need to differentiate that function with respect to time. The 100 is going to disappear and we're left with minus 10, and we will write 2 root 2, which is virtually minus 5 over root t. So our q dash is this. So using this rate of change, if we wanted to have a look at someone who is 25 years old, we would insert that in as minus 5 over the root of 25, and that will give us minus 5 over 5, which is equal to minus 1 unit. We'll just call them units in terms of chemical change. And this translates to saying that the quantity of chemical is decreasing by 1 unit per year. Okay, so what happens when a person is 50? We insert 50 in here and we get that 50 root 50. Okay, well, we're working with thirds over here. You can rewrite this again as saying it's 2 times 25, which would be the same as saying 5 over root 2 multiplied by root 25. And we know that root 25 is just 5, so we can say minus 5 root 2, which is, cutting this out, minus 1 over root 2 units. And if we look at the graph itself, the person who's age 25, and looking at the slope in here, you'll notice that that slope here is meant to be equal to minus 1, whereas the person who's aged 50, their slope is not as steep, and it is here at 1 negative minus root 2. So it's useful to have a look at these graphs. Okay, so for our last question, we want to show that the quantity of chemical is decreasing for all t is greater than 0. This can only be answered by looking at the derivative function. Our derivative function is this, minus 5 on root t. Well, this means that root t is always greater than 0. It also means that minus 5 over root t must be always, therefore, less than 0. Therefore, q dash t is always less than 0, which means that it is decreasing. For all t is greater than 0, and remember that t cannot equal to 0. Just write that down, t is not equal to 0.